light. So we know that basically talking about the light, the source of the light on earth is basically the sunlight. Getting it now? We see it every day, every morning. That is sunlight. Specifically, especially talking about light, like what is light right now? We see that different objects give light, like a sun would be giving light, fire would be giving light. But what actually is this light? So we see that light is a source of, or light is a form of energy which enables us to see different things around us. So that is what light is. Light is basically a, it's not a physical thing that we can touch or that we can hold or that we can store, but rather it's kind of a radiation that can be detected by our eyes, that can be detected by the human eye right now. So we see that it's a form of a electromagnetic radiation, it's a form of a energy which enables us to see different things around us, which gives us the sense of vision. Without light we wouldn't be able to see anything around us. Getting it now? Like, what is darkness? Darkness is basically absent of light now. So when there is no light, you don't have the sense of vision. You don't get to see anything around you. So light is basically a form of energy. So far, we have understood this thing.
Yes,
Then,
sir.
then another thing is that we get to see that this light now, it will be produced. It will be produced by certain kind of objects in the universe only, right? Like for example, suns, stars, right? Various other objects that we see on earth, like a fire, like candle, a torch bulb. Getting it now? These are the objects that will be emitting their own light, and hence we classify them as luminous objects. Getting it now? We classify them as luminous objects. So far what we have learned, that light is a form of energy, right, Kadeejath? It's a form of energy.
Yes,
Furthermore,
sir.
it gives us sense of vision. Without it, we won't be able to look at anything around us. Got this further? Okay. Furthermore, talking about light now, we always get to see that light will be traveling in a straight line. Huh? Light will be traveling in a straight line. It will not be traveling in a zigzag fashion. It will always travel in a straight line. So the question comes that how do we get to prove that light travels in a straight line? So we can have a following setup. For example, if I were to place a candle over here, this is the candle flame, and I were to place some wooden blocks over here. Let's say I have taken 3 wooden blocks and each of them has been placed at equal distances in front of the candle. Getting it? And on the other side, let's say you are watching it. Okay. And I have made holes on them at equal distances. Okay, now at equal distances, I have made holes in them. So thereby what I noticed that the light rays will pass via the holes made in this cardboard and it will reach our eyes. Hence, we'll be able to look at the candle flame. The candle flame will be visible in this case. Getting it? But what if we were to make, instead of making hole at this point, at this place, what if I were to make the hole in the second one at this place? Now, in this case, will the light rays reach our eyes? It will not. Getting it, Kadeejath? What happens in
Yes.
this case now? The light rays will be passing via this hole, but as it falls on this hole, since the hole now has been changed to this position, so thereby light rays will be getting reflected from the surface and it will not pass via it. So what do we conclude from this setup? That light travels in a straight line. Light travels in a straight line. Getting it
Straight
now?
line.
So that is another property of light, that it always travels in a straight line. Okay. Furthermore, you tell me that if you were to look at the medium between medium outside the atmosphere of the Earth, is there any medium outside the atmosphere of Earth? This is our planet Earth. This is the atmosphere. Okay, so this is the layer of gases that is covering our Earth's surface that we call as atmosphere. Getting it? Now over here you have, let's say, millions of kilometers away, you have the sun. Getting it now? We have the sun over here. So as the sun's rays passes from the as the sun's rays are coming from the sun now, is there any medium over here? This is basically, this space is basically empty now. There's a vacuum in the space. There isn't any particles, any medium in the space. So we see that space is basically vacuum. It doesn't have any particle in this. So there is no medium between the Earth's atmosphere and the sun. All that is there is basically vacuum. Getting at this concept?
Yes, sir.
Yes. Okay, no. By medium, basically we refer to the solid gases or liquid medium. Right now, anything that will have particles in it, that particle in it will form the medium. Like the atmosphere has got particles of different gases, molecules of different gases are there in the atmosphere. So thereby the atmosphere is a medium. But before that, no, between the sun and the atmosphere there isn't any medium. So hence, if there isn't any medium, so it is basically vacuum. So even in absence of any medium, when there isn't any medium, light still travels. So that is another property of light, that it can travel in vacuum. So medium is not required. Medium is not required for the propagation of light. For light to travel, it doesn't require medium. While you would be aware of this thing, like if two astronauts have to communicate in space, how do they communicate? Hmm? Ever wondered about this, that how two astronauts communicate with each other in the space? Hmm? They would be taking help of some transmitters. They would be taking help of some radio waves in order to communicate with each other. They will be having some special devices. Getting it now? That's how they will be able to communicate with each other, right? Because there isn't any medium in the space. So if an astronaut standing on the moon wants to communicate with the other person, he won't be able to communicate into the vacuum, in the vacuum. So he will have to take help of some special communication devices. Getting it now?
Yes, sir.
So that is one thing. So thereby, so light doesn't require any medium to travel, but in contrary to that, we know that sound requires medium to travel. That is one thing. So far, hope you have understood what we have discussed. Furthermore, we know that in the universe there are two kind of objects. One that will be emitting the light. For example, you have stars. Stars would be emitting the light right now. Certain chemical reactions are going on inside the stars now, right? Ever wondered about what kind of reaction goes on in the sun? What is happening there that it produces so much of light? Yes, ever wondered about this thing? So basically, there what is happening now? Certain kind of reactions, like for example, basically what happens? Two hydrogen atoms would be combining there. Okay, na? Two hydrogen atoms would be combining. Basically, nuclear fission takes place. Nuclear fission fusion takes place. I mean to say, nuclear fusion takes place in the sun. That releases enormous amount of light and heat. That releases enormous amount of heat and light. So in this, what will be happening now? That two nucleus will be merging together, like we have two hydrogen atoms. Okay, now say there are two hydrogen atoms. You know what are atoms? Atoms are the smallest particles of anything. Okay. Atoms are the smallest particle of anything that we have. Getting it? Even in our body, we know that the cell is the fundamental and the structural unit of the human body or any other living organism. But even smaller than cells, we have got atoms. So atoms are the tiniest thing that you can imagine, and you will have to take help of certain microscopes in order to look at atom. So what I'm trying to say that basically two hydrogen atoms would be combining together. It would be combining together. It would be fusing together basically to give rise to helium. To give rise to helium. And in that process, now lots of energy is released. Lots of energy is released in the form of heat and light. So that is what goes on in the sun. You'd be studying about it in the later classes in much detail. So that's how sun would be giving light, right? Furthermore, we have certain other objects on Earth, like a candle, like burning wood, like a torch. They will also be emitting out their own light. So on that basis, we have two kind of objects. One is called as luminous. Another one is called as non-luminous objects. Getting it now?
Yes,
We
sir.
have two kind of objects. So on the basis whether they emit their own light or not, on that basis we have two type of objects. We have luminous and then we have non-luminous. Examples of luminous objects would be all the stars. They are luminous in nature, right? What about some other objects, like for example candle flame, torch bulb, etc. Then talking about non-luminous, for example moon.
Plants.
Planets, we can take example of that. Different planets, you mean to say? Yeah, planets. Getting it now? Everything that we see around us, pretty much majority of the things that we see around us, they are non-luminous in nature. That is one thing. So far we have learned about various things about the light. There are few more properties of light. For example, whenever light would be falling on an object now, whenever light would be falling on an object, it might either be reflected, it might either bounce back from the surface, it might either go into the surface. Two of the things will happen. Say for example, you take a mirror, and if you were to direct the torch light over this mirror, so what we observe that as the light rays would be falling on this mirror, it will bounce back, right? It will bounce back. But in the case of, let's say you have taken a tub of water, and if the light rays were to be projected into this, if the light rays are falling in this tub of water, so it will pass into the water. Only some amount of it will be reflected back, but majority of it will pass into the water. Getting it now? So it might either get bounced back from the given material, or it might either go into the material. That is one thing. Okay. Furthermore, talking about how do we really see the objects? Like, how are we able to see the different objects around us? That is one question we have. Hmm? So as you can see over here now, as the light rays are coming from the sun and as it falls on the rose, so you can see that the light rays are bouncing back from the surface of the rose here, right? And here basically that bouncing back is called as reflection. So as the light rays are reflected from this rose now, so those reflected light rays now goes to our eyes. Those reflected rays now goes to our eyes. Getting it? Now, as we know that our eyes are quite complex structures, there what happens now, as the light rays would be going into our eyes, so then what will happen? Those light rays will basically, it will be combining together. For example, light rays that were entering into our eyes, for example, these are two light rays. Okay. These are two light rays. And as it passes via the eye lens now, then it will start to bend towards each other. Getting it, Kadeejath? It will start to bend towards each other, and then it will finally intersect each other, converge at a point over here. Getting it?
Yes, sir.
They are meeting at this point. Furthermore, over here now there's a structure called as retina. There's a structure. Look at where I'm pointing. This structure is being called as retina. Okay, now. So now this
Okay.
retina will be now sending this information to the brain, and the brain will be processing it as image. So basically, what is happening? In order to look at any object around us, how we are really able to see the objects now, it is because of reflection. How we see objects, it is because of reflection. That is how we are able to see the objects around us. As the reflected light rays would be entering into our eyes, then we are able to see the objects. That is one thing. Now, moments ago, as I told you that whenever light rays would be falling on a surface, it might either get reflected back or it might either pass into that medium. Talking about the first case when it will be getting reflected back. So the manner in which reflection of the light rays will take place, it will depend upon several factors. But first of all, let us understand what reflection is. So as the light ray will be falling on a very smooth and polished surface, what we see that the light rays as it is coming in this manner, then it will be getting reflected back into the same medium from where it was coming. Like the light rays are coming from air, and let's say this is a polished surface like a plane mirror. So as the light rays strikes the surface of the plane mirror, it bounces back into the same medium, that is into the air. That is what reflection is. It's the phenomena of light bouncing off surfaces. That is what reflection is. Hope that is clear. Getting it now. Furthermore, whenever reflection will be taking place from a very fine and from a very well polished or shiny surface, so in that case, what happens? The way in which light rays would be incoming and way in which it will be bouncing off, it will be following some rules. It will follow some rules. We should be learning later on. As of now, look at these two surfaces. Here you get to see that specular reflection is taking place, or we see that regular reflection is taking place. Instead of this, we call this as regular reflection is taking place. Why is it so? Because the surface is kind of smooth, and hence you can look over here that they are falling on this object in a particular fashion, and they are getting bounced back from this in a particular manner. Okay, now all of them would be following some rule here we should be learning later on. But if it is a rough surface, if it's an even surface like in this one, if the surface is not even, so in that case, the light rays which are incoming, they are incoming in a particular fashion. But when you look at the reflected light rays now, they are not reflected in a particular fashion. Getting it, Kadeejath? So
Yes,
how
sir.
it is happening, we'll be learning about it in a moment. Okay, now. Furthermore, there's one more thing to be discussed is that furthermore, talking about the reflection now, basically what happens if it's a plain surface, plain and a smooth surface like a plane mirror. Let's say that this is a plane mirror, and this is an incoming light ray. By the way, you understand the words like rays now, like what is a ray? We have studied about it in mathematics. Yeah. Ray is basically a line which has a starting point but doesn't have any ending point. It is
Yes,
denoted by
sir.
this symbol. No? It has a starting point but doesn't have any ending. So when we say light ray now, so you can relate it to this thing. So this is an incident ray. What does incident mean? It means incoming. Okay, now incident means that is something that is incoming. So this is incoming light ray that falls on this and it will bounce back. Now, right now, what we are learning, right now we are learning about laws of reflection. Laws of reflection. And the laws of reflection, we are learning it in context whenever whenever reflection will be taking place from a plane mirror or from any smooth surface. There the laws of reflection will be applicable. So what we observe here, as the light ray will be falling on it, so then it will be reflected also. So this ray is being called as a reflected ray. Now there are some rules of reflection that will be applicable whenever light rays will fall on a very smooth and plain surface. Okay. Now right in between the incident ray and reflected ray, I am drawing a perpendicular line. Okay, now I am drawing a line perpendicular to the surface of the plane mirror. Getting it, Kadeejath?
Yes, sir.
Okay, no. This perpendicular line of this basically makes a degree of 90 degree with this. Okay, now if you're getting confused, like what is this? This basically makes a angle of 90 degree with this. So the angle over here, this is 90 degree. Let us understand the main thing. The main thing here to be discussed is that now this angle of incidence, this angle, by the way, you should know that this line is called as normal. Okay, now. So the angle that is formed between the incident ray and the normal, it is called as angle of incidence. What do we call this as? Angle of incidence. Getting it, Kadeejath?
Yes, sir.
Okay, then look at this another angle that is formed over here. This is being called as angle of reflection. Okay, angle of reflection. So the first law of reflection says that when first law of reflection says that angle of incidence is always equal to angle of reflection. These two angles will be always equal to each other. For example, let's say that this is now 30 degree. So this one will also be 30 degree. Got this now? Yes. Both of them is 30 degree. The first law states that angle of reflection is always equal to angle of incidence. Hope that is clear. Yes, Kadeejath.
Yes, sir.
That is the first law of reflection. Did you understood this?
Yes, sir.
Okay, so what does it state? Yes. What is the first law of this reflection state? It basically states that the angle of incidence is equal to angle of reflection. Getting it now?
Yes.
Okay. Okay, so as of now, by the way, there are two laws of reflection, but you have to study the first law only. Getting it? Okay. Furthermore, in the chapter, we have to especially we have to study about concepts like pinhole camera. We have to talk about uh, special cases where reflection will be taking place like multiple times. Okay, we will be learning about that too. But before that, let us understand about different kind of objects like what are transparent, translucent, and opaque objects. Okay. So just a minute here. Now, on the basis of how much of light can pass through an object, we have basically three kind of objects. On the basis of how much of light an object will allow to pass through it, you have got three kind of objects. Like for example, see that we have three objects over here. There's a glass beaker in which clear water is being poured. It contains clear water. There's another glass and that contains milk in it. Okay, and there's another object over here, like there's another glass beaker that contains sand. This is filled with sand. So we have got three different materials over here. Hmm. In the first case, it's a water. Second one, you have milk. The third one, you have sand in this one. Now, if I were to give you a torch and I ask you to do the following observation, like when you project the torch light over this, over the first glass beaker, what do you observe? Will all the light ray pass through it, or just a fraction of the light ray will pass through it? Will all the light ray coming from the torch pass through this clear water, or just 50% of it will pass through it? Obviously, all of it will be passing through it now.
Yes, sir.
Getting it now? So thereby, this kind of object that allows all the light to pass through it, we call them as transparent object. Getting it now? That is called as transparent object. Then in the milk, what will be observed? That only partial amount of light will pass. Getting it now? Let's say like 50% of light passes through it. 50% of light passes. Getting it now? Also, you would have seen like certain kind of glass, like a frosted glass. Now the glass of the window, it will not allow the light to pass through it completely. Right now, there are different kind of glasses. Some of the glasses will allow 100% of the light to pass through it, but some of it will not allow. So we have got examples of some glasses also other than the milk. Like we can take example of frost glass also, which allow only a fraction of light to pass through it, and those objects are called as translucent object. So hope that is clear. Getting it? Then the third category of material is called as an opaque object, because it will not allow any light to pass through it. For example, a piece of stone or piece of cardboard block, uh, getting it now, that will not be allowing the light to pass through it. Hence, they are called as opaque object. Opaque object. Is these three type of objects clear to you? Water, transparent, translucent, and opaque objects?
Yes, sir.
Which one of them will not allow the light to completely pass through it?
Opaque object.
Opaque object, good. Now, there's another observation to be made, that whenever in the path of light, whenever an opaque object is placed now, whenever the flow of light will be obstructed, then it will lead to formation of shadow. That leads to formation of shadow. So say for
Shadow.
example, again we are projecting torch light, okay, and in front of this, let's say a cardboard block has been placed, a cardboard has been placed over here. So as the light rays will be falling on this, so we will observe that the shadow of this cardboard will be formed. The shadow will be formed. So what is the condition necessary for the formation of this dark shadow over here? That whenever the flow of light is obstructed by an opaque object specifically, then it leads to formation of shadow. Getting it?
Yes, sir.
Furthermore, you would have observed, we'll observe, like if I were to bring the object close to the torch, or if I were to bring the torch closer to the object, the size of the shadow will increase. Getting it? The size of the shadow keeps on increasing as the source of light or if the object is brought close to it. Like as a kid, you would have done this. Like if you will take a flashlight, and if you were to place your fingers in front of this, on the opposite side on the wall, you can see the shadow formation of shadow. You can observe it on the wall. And if you were to bring it close to the flashlight, the size of the shadow increases, isn't it? Talking about shadow formation. So what we learned about shadow? Yes. What we learned about shadow? Yeah. What? What is a shadow?
Shadow
Shadow
is
is
a dark path formed when an opaque object comes in the path of light.
in the path of light, right now. So basically, it's a dark shape or a dark area that will be formed, that will be created whenever an object of, for example, a person would be blocking the light from reaching a surface. Right now, getting it now. That is the condition for it. So it is a dark shape, shape or area that is created when an object blocks the flow of light. Now talking about what are the conditions required for formation of shadow, when it will be formed. So three things are required for formation of shadow. The first thing is a source of light. No, like
Yes, sir.
in the night, shadow is not formed. No? Usually, if there isn't any source of light, shadow will not be formed. Second thing is an opaque object. Opaque object. Third will be a screen on which shadow can be obtained. Like for example, this is a table. Let us say this is was a table on which it was placed. So the screen was the table on which shadow was formed. It could be a wall or it could be any other thing. That is one thing. Furthermore, if you were to talk about the factors that will determine the size of the shadow, now it will be basically closeness to the source of light or the size of the object also. So talking about size and shape of the shadow, so size and shape, it depends upon distance between the object and the light source. Got this now? If this distance is reduced, so thereby the size of the shadow will increase. If the distance is increased, then opposite will happen. Then the size of the shadow will decrease. Getting it now? That is one thing. Okay.
Sir.
Also shadow can be created by natural things also. It can be created by artificial things also. Getting it now? Like for example, you'd have, as you happen to walk on in the street, so the shadow of the leaves are also formed. Getting it? That is one thing. Okay. Now also you'd have observed like the size of the shadow of we humans also change during the day. Hmm? Like in the afternoon or in the morning and in the evening, you'd observe that the size of the shadow changes. Hmm? Like what happens in the morning time? Like in early in the morning, what happens? Say, for example, there's a tree over here. There's a tree, and let's say morning, afternoon, and evening. So what we observe that during the noon time or during the afternoon, the size of the shadow of this tree will be smallest. It will be like this. Getting it? In the morning and evening, what we observe that the size of the shadow is longer. We observe that the size of the shadow is usually longer. Why does that happen? It is because of the direction of the incoming sun's light. Getting it? So try to visualize this thing. Say that this is where the sun is, this is where the sun is over here, and this is where the sun is at this time. And these are the incoming sun's rays. These are the incoming sun's rays over here. So what are we observing here? Hmm? During the afternoon, the sun's rays are directly overhead. They are directly overhead. The size of the shadow is the smallest because of that. Hmm? Furthermore, during the morning or during the evening, the sun's rays are not directly overhead. They are slightly tilted. They are slanted, and hence the size of the shadow is longer. So, with respect to the direction of the sun's rays, also the size of the shadow will change. Getting it now? So that is clear. Okay, that is one thing. Okay. Also, do tell me that in your school you must have studied about concepts like pinhole camera or what a periscope is. Yes, Kadeejath?
Yes, sir.
Okay. Although the time is over, so do one thing. If your classes get scheduled now, in other classes we can discuss about those concepts. Okay. Now, basically, periscope would be basically an instrument that would be used to view the things that would be on the surface. Like it's not practically possible for the submarine to come to surface every time. Like if there's an enemy ship nearby this submarine, no? So in order to look at it, basically with the help of periscope, they will be able to look at the enemy ship because this is submerged deep in the ocean. So practically, it's not possible for this submarine to come to the top every time. So basically, with